It's more than a hope, it's a guarantee. Wow. I mean, just pause for a second and let that really sink in. In astronomy, our understanding of the universe literally changes with almost every new telescope that goes up. So absolute guarantees, yeah, they are incredibly rare. When a top-tier scientist uses a word with that much weight, you've absolutely got to stop and listen. And honestly, that's exactly what we're looking at today. We are looking at a promise of something truly monumental.
Welcome to today's Explainer. We're unpacking the unbelievably audacious guarantee behind the 10-year movie of the universe. Get ready, because we're bringing some serious cinematic energy to the cosmos today. You see, we're not just taking those deep, static snapshots of the night sky anymore. Oh no. We're setting the stage for a massive, high frame rate mapping project that's going to track literally billions of galaxies in motion. We are talking about a full-blown feature presentation of the universe itself, and it is poised to completely change how we look at the celestial mechanics going on right above our heads.
All right, part one, a mind-blowing guarantee. Okay, let's dive right into this. The scientific leadership behind this project, they are not just using PR spin here. They are straight up promising a paradigm shift. They aren't saying, oh, this will slightly advance our understanding or we'll get some sharper data sets. No, they are guaranteeing that the sheer volume of transient events, and by that I mean supernovae exploding, massive asteroids zipping by, entire star systems shifting, is going to fundamentally shock us. The magnitude of this data is just staggering. We are looking at a system built to process 20 terabytes of data every single night. To put that into perspective, that level of data capture means they aren't just hunting for specific events anymore, they're casting a net so unbelievably vast that discovering the completely unexpected is practically a mathematical certainty. Moving on to part two, the 10-year universe movie.
10 years. Now, that's not just a really long time to wait. It's an entirely unprecedented baseline for an astronomical survey. We're not talking about snapping a quick picture or doing a single week of observation here. By keeping a continuous, unbroken focus on the exact same patches of the southern sky for a full decade, astronomers can finally track those long-term celestial mechanics that static images just totally miss. It basically allows scientists to build these long-term light curves, to actually see how objects brighten, dim, and evolve over an incredibly extended period. We're essentially establishing a 10-year cosmological heartbeat. It gives us the exact temporal resolution we need to spot patterns that take months or even years to play out. And that is something traditional, time-limited telescope access just absolutely cannot provide.
Think about how we usually view space. We picture these beautiful frozen galaxies, right? But the reality? The universe is a violent, highly active place. And this whole project brilliantly illustrates exactly how we're changing our approach to that. By imaging the entire visible sky every few nights, we are essentially filming a documentary. It's wild. We'll literally be able to watch stars explode in real time. We can track the precise orbits of potentially hazardous near-Earth asteroids, and we'll actually watch the subtle distortions of dark matter shifting over time through a process called weak gravitational lensing. This project is a massive, monumental shift from still astronomy to a moving, living cosmic cinema. It's taking our view of the cosmos from a flat, static photograph and turning it into a sprawling, dynamic ecosystem. And that brings us to part three, the Rubin Observatory's promise. So here's the really crucial point. All this cinematic hype, it is anchored by some serious scientific authority. Chief scientist Tony Tyson actually expects this project to completely rewrite the textbooks. We are talking about the Vera C. Rubin Observatory down in Chile. This facility is equipped with a 3,200 megapixel sensor. Let me say that again, a 3,200 megapixel sensor. It's the largest digital camera ever constructed in human history. To really wrap your head around that scale, you would need over 300 ultra-high-definition TVs just to display one of its images at full size. That is mind-boggling. When the chief scientist of a facility with that kind of unparalleled next-level technological power puts his reputation on the line to say our minds will be blown, well, it definitely elevates this from just an exciting concept to an impending scientific revolution. Which naturally leaves us right here with the ultimate question. If this 10-year dynamic survey is a literal guarantee, what hidden cosmic secrets, moving and shifting around in the deep, dark depths of space, are finally going to be caught on film? I mean, will we finally map out the elusive web of dark energy? Are we going to find Planet 9 lurking way out there in the outer solar system? We know the movie is coming, and the largest digital camera ever built is just about ready to roll. So now we just have to grab our popcorn and wait for opening night.